Welcome to The Explainer. Today, we're going to break down one of the most powerful tools ever created for understanding the world, the scientific method. And look, this isn't just for scientists and lab coats, okay? It's a seriously practical toolkit for clear thinking that you can use, well, every single day.
So here's what we've got on tap. We're going to start with the big why, then we'll walk through the 6 core steps, and finally, we'll see how it all comes together with a really cool physics example.
How do we actually get past all the guesswork and opinions to find answers we can rely on? How do we separate what's real from what's just noise when we're trying to figure something out?
This is the fundamental question, right? It's what drives every single discovery. And to get reliable answers to that question, humanity had to come up with a system.
And that system is the scientific method. But don't think of it as some rigid, boring set of rules. It's more like a logical framework for investigating the world around you, whether you're a rocket scientist or, just trying to figure out why your houseplants keep dying on you.
And believe it or not, this is not a new idea. Its roots go all the way back to the 11th century with the physicist Ibn al-Haytham. He's pretty much considered the father of the whole thing. It got formalized during the scientific revolution, and yeah, today it is the absolute gold standard for research everywhere.
Okay, so let's get into the nuts and bolts of it. Let's see how this all builds into a repeatable blueprint you can use for any kind of discovery. So here they are, the 6 essential steps. It all kicks off with a simple observation, something that just makes you go, I wonder why that happens. From there, you do a little digging, form a testable prediction, run your experiment, crunch the numbers, and finally, you tell people what you found out.
Now, this part is absolutely crucial. A random guess just isn't going to cut it. The real heart of the scientific method is making a smart, informed, and, most importantly, a testable prediction.
And that prediction? Well, that's what we call a hypothesis. It's basically your proposed explanation for what you've seen, and it becomes the foundation, the entire bedrock for the experiment you're about to design.
But here's the thing. Not all hypotheses are created equal. A really strong one has 3 key traits. First, it has to be falsifiable. That means there has to be a way to actually prove it wrong. It also has to be specific, so you know exactly what you're testing. And finally, it's got to be measurable, so you can collect some real, hard data.
Okay, check this out. This is the difference between a regular hypothesis and what's called a null hypothesis. Your main hypothesis predicts some kind of effect, right? Like eating an apple every day will decrease doctor visits. The null hypothesis is kind of the opposite. It's the default assumption that there is no effect. In a lot of experiments, your real goal is to gather enough evidence to say, sorry, null hypothesis, but you are wrong.
All right, so you've got your strong hypothesis in hand. The next big challenge is designing an experiment that can give you a clear, straight answer. And this is all about making it a fair fight.
So to make that fair test, you have to get to know your variables. The independent variable, that's the one thing you change on purpose. Think of it as the cause. The dependent variable is what you measure to see if anything happened. That's the effect. And the controlled variables? That's everything else. All the stuff you have to keep exactly the same so it doesn't mess up your results.
And the whole reason for controlling those other variables is to avoid these little troublemakers called confounding variables. These are the sneaky outside factors that can creep into your experiment, totally confuse your results, and make it impossible to know if the thing you changed was actually responsible for the outcome. All right, so that's a lot of theory. How about we see how all these concepts actually come together in the real world? Let's take a look at a practical example from physics.
So our investigation starts with a really clear, focused question. Maybe we've noticed that when you throw a ball, the angle you throw it at seems to change how far it goes. So what's the deal here? What's the relationship? From that simple question, we build our hypothesis using that classic if-then format. Notice how specific this is. It's measurable. We can measure both the angle and the distance. And it's totally falsifiable. We could do the experiment and find out the angle has no effect at all.
So now, we nailed down our variables to make sure it's a fair test. Our independent variable, the thing we're intentionally changing, is the launch angle. The dependent variable, the result we're going to measure, is how far the projectile goes. And to make sure our results actually mean something, we have to control everything else, like how fast we launch it and the mass of the object.
So you run your experiment, you get a result. And you're done, right? Well, not so fast. Getting one answer is almost never the end of the story. Science isn't just a straight line to a single, final answer.
The truth is, the scientific method is a continuous loop. It's iterative.
The conclusion from one experiment very often becomes the observation that sparks a brand new question. It's this constant, never-ending cycle of questioning, testing, and fine-tuning our understanding of the world based on actual evidence.
So, what's the big takeaway from all this? The scientific method isn't just for science class. It's an incredibly powerful framework for thinking critically. It's really all about asking good questions, making predictions you can actually test, and designing fair experiments to find answers you can trust.
So I want you to think about it. From figuring out the absolute best way to brew your morning coffee, to improving your workout, to making your garden grow better, what's an everyday question you could investigate using this exact process? Let us know in the comments. And hey, if you found this explainer helpful, do us a favor and hit that like button and subscribe for more. Thanks for watching.